Hello everyone, Mr. Minnick's my name, math is my game, and today we're looking at this homework assignment for Algebra 2. And before we look at the exercises that I assigned, I just want to say one or two things about homework, and quizzes and tests and your grade. We're coming upon the season of the interim. And so basically with homework assignments, we'll have homework 2.1 and 2.6 and 2.7, and they're worth 5 points each most of the time. Most of the time they're worth 5 points each. So if you think about it, if you hand it in and you do like one or two problems, if you only do one, I'm probably going to give you a 1 out of 5. But if you do 3 or 4 of the problems, most of the time I'm going to give you a check and a check and a check. And as long as you show up to class and hand in your homework, chances are you're probably going to get 100% in this homework category, as long as you hand something in. Okay. Suppose you miss the occasional one here or there, there's going to be some opportunities for bonus. So let's say worst case scenario, maybe you get an 89% in this category. Okay. I've said this before and I'll say it again. The homework, it's not so much about handing it in and getting the 5 points. It's not even so much about, when we go over it, about writing down the right answers. What it is about is after you've seen what the right answers are, if you didn't get them the first time around, go back and see if you can do that. Because the quizzes are going to be similar to the homework. When I give a quiz and there's 60 points possible, like on this 2627 quiz, and there's 60 points possible, but I take it out of 50, and you get like a 10 on it, I know that you're not doing the homework. I know that you're not looking back over it trying to figure out things that you missed. I'm no dummy. I don't want to sound like I'm bragging, but I did very well when I was in school because I worked hard. And when I was in college, I did very well. I'm no dummy, though. I know I can get it. I understand when somebody gets a 15 out of 50 on the quiz that they're not paying attention in class, that they're not going back and reworking the homework. So anyway, what I want to kind of do real quick is show you how your grade's calculated, because I think some people don't get this. So the way your grade is calculated, I use what's called a weighted grading system. And let's just finish out this scenario. Suppose you end up with an 89% in the homework category. And suppose you're a lousy quiz taker and you're getting 24s out of 50. That's going to be like a 48% in the quiz category. Chances are, if you're doing that bad on the quizzes, you're probably not going to do much better on the tests. But suppose it's a multiple choice test and you get lucky and you guess good and you end up with a 65% here. So let's see how that plays out in the grand scheme of things with your grade. Let's see how that plays out. If you don't know it, your homework makes up 20% of your grade, and this calculator is totally not cooperating with me. Try that again. It's going to be a long day in room 203. Did you guys see me hit the reset the calculator? And oh, there it goes. Okay. So here we go. 89%. 89% at 20 plus 48% plus 48% at, how much are quizzes weighted at? Does anybody know? 30. And then finally 65%, and what's that leave for tests then? Tests are weighted at 50% of your grade. So if you got 89% of the homework points, 48% in the quizzes, and 65 on the test, do you think you're passing? I don't know. It's going to be close. That's not bad. You're passing. You're passing. So what happens if you maybe don't hand in the homeworks and you get a 69% in the homework category? Well, you're still passing by the skin of your teeth. What happens, though, if you do really not so good on the tests. Maybe you get a 45 here on the tests. Oh, that's a tough deficit to overcome. Anyway, the point I want to make, when we go over this homework, I expect you not to be on your phones. When I turn my back, I expect you not to have your phone out texting and pretending like I don't see you, because I do. When we go over the homework, the expectation is you're going to write down the right answers, you're going to pay attention. Later that night, you're going to go back and see why you didn't get it. And if you still didn't get it, then you're going to ask somebody, hey, I don't get this. What can we do to remedy this? So anyway, I'll shut up about that and we'll look at the homework. Here we go. Number 6. Number 6 is the first one. The directions said, the graph of negative 2x, or f of x equals negative 2x, is shown. Describe the transformation and graph it. So in number 6, when we do this, I'm gonna cut this out on a new page, I think, just so we can see it in a little bit bigger image here. Go ahead and cut this, put it on a new page. Oh, I should have put that on a new page. Oh well. Cut. Paste. 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 There it is. Okay, so when we take that function and we double it out front, what that does, if you remember what we talked about yesterday, that's anybody remember what it's called? When you double the thing? A vertical stretch by a factor of 2. Okay, so they're asking us to describe. So this multiplying by 2, that means we have a vertical stretch by a factor of 2. And then when we add the 1 on the end, when we add this 1 on the end, that takes the thing and translates it or moves it up. And we actually call that a vertical translation. We call that a vertical translation up 1. So what they want us to do then is to graph that. I'm more concerned that you can describe it rather than graph it. Describing it, to me, is more important than being able to graph it. So when you graph it, what's going to happen is the steepness of this thing, the y values are going to be twice as great. So what I'd have to do is this 0, when I double 0, it doesn't change. But when I double 2, this is going to be a little bit higher here, and this is going to be a little bit lower here. So the steepness of this line is going to change. And it'd be really nice if you could do this on your notebook paper, but you can't. So I double the steepness, and it's translated up 1 unit, so it would look like that, actually. Okay. It would look like that, actually. Okay. So I don't know if you graphed them or not. Like I said, I'm not really concerned that you could graph it. I'm more concerned that you can use the appropriate language and describe the transformations. Vertical stretch by a factor of 2. Vertical translation up 1 unit. Any questions, comments, concerns about number 6? Yeah, question. The point there, what, this point here? This one up here? Okay, yeah, so what I did is I kind of looked at the original function, and I looked at the original function and said, well, it goes through this point. So because of this 2 here, I'm thinking, well, that height's going to double, so it is going to move up to here. And then because of that +1 at the end, I got to move it up 1 more time. I don't know if that answers your question. Yeah. So that point over here, when I have an x value of -1, it did go all the way up to 5 there. I don't know if that answers your question. Okay, good question. Really good question. Similarly, when I looked at the original graph, I went down 1 and over 1, and the new one, it's going to be going down 4, but then because of that +1 at the end, I ended up bringing it back up 1. So, okay. Like I said, again, I'm more concerned that you can describe that it's a vertical stretch by a factor of 2 and a translation up 1 than I am the graph so much. We ready to move on to 8? All right. So taking a look at number 8 then, if I'm being honest with you, 8's one of those tricky ones. Some of the classes got a different lesson than the others, I did maybe mention this in 2 of the classes, maybe not all of them. So if your class didn't get this, here's the secret to this one. It says, can you give an example of a function where a horizontal translation gives the same resulting graph as a vertical translation? Explain. Anybody think they figured this one out? What do you got? Oh, you watched the YouTube video on my YouTube channel. So what'd you come up with? Y equals parentheses x plus 4, and then y equals parentheses x plus 4 like that. Wow, yeah. So the deal is, if we compare all those to the parent function, get my line ending with the right stuff here. The parent function kind of does one of these things. One of these things. The blue function says we're going to take that function. Well, I got to clone it first. I want to clone that. So the blue function says, okay, well, because the plus 4 is at the end, I'm going to drag that thing up 4 units. I'm going to drag that thing up 4 units. And the red one, the way the parentheses are written, I'm going to drag that thing to the what? To the right or to the left? To the left 4 units. Okay. And dragging the thing up, the line whose slope is 1, dragging that line up 4 units is the same thing as dragging that line to the left 4 units. So, what was the question? The question was, can you give an example of a function? Yes. A line whose slope is 1. You can take any line whose slope is 1, other than the parent function. The slope even could be -1, and I'm pretty sure it'll be the same thing. So maybe I could even say, yeah, a line whose slope is plus or minus 1. Because when you drag it up, dragging it to the left is going to be the same thing. I'm really impressed that you went back and watched the video. Good one on you. Right on, right on. Good. All right. Does anybody else think they have something else that might work on that one? Because really, that's about the only one that works. A line whose slope is 1. Let's just see if we could do that with any other function, just to see. Lock. Suppose we had something that looks like this. We're going to grab stuff like that in a future chapter. So I'll clone that. I'll make this one blue, and I'll clone it again, and I'll make this one orange. So if I take the blue one and I drag it up 4, is that the same thing as dragging it left 4? Not exactly. Not exactly. So really the only thing that's going to work there is that line whose slope is either 1 or -1. All right. Moving on then, we're looking at number 9. Number 9, I'll cut out and put on a new page so we can see it big. Oh, that's another thing I've been wanting to talk about. I don't assign seats unless I see the need to, and most of my classes I don't see the need, but there's 1 or 2 where I think maybe it might be an effective thing. I see some people that sit all the way in the back, and I see them squinting like, I can't see. There's a lot of seats in the front. There's a lot of seats in the front. It kind of reminds me of going to church. I know you guys know that I go to church. I'm not preaching, but when you go to church, nobody sits in the front. Except the musicians. That's where I sit. I sit in the front. So anyway, find a new function, g of x transformed from this that's perpendicular to f of x. Now, I didn't talk about this one in the notes. So they got transformed from -x minus 2. So -x minus 2 is going to have a slope of -1 and a y-intercept of -2. So I'll start here. Slope's -1, up 1 and over 1. And up 1 and over 1 again. So basically, this is what they're giving us in the beginning. They're giving us that thing. They're giving us that. And they want something perpendicular to that. From geometry, from Algebra 1, you should have remembered something about perpendicular lines and their slopes. They're going to intersect. They're going to intersect in a right angle. But there's something about the slopes. Slopes of perpendicular lines are, there's two words that we mentioned. Yeah. Opposite reciprocals. Nice. Good one on you. Opposite reciprocals. Opposite reciprocals. So in other words, if you take the one slope and you multiply the one slope by the other slope, the product would equal -1. So for instance, if one of them had a slope of -3/4, I said -3/4, and the other one had a slope of +4/3, that product would equal -1. But here, the slope here, the slope here, the slope of this line is -1. So we need -1's opposite reciprocal. What could you multiply by -1 to get -1? +1. Thank you. Nice. Good. +1. So g of x then, this g of x, all it has to do is have a slope of 1. So for g of x then, we could say g of x equals 1x plus anything. Plus anything. Plus alpha plus pi plus the square root of 7. Who cares? It's plus whatever. As long as its slope is 1. Now I know that most of you probably don't have your own graphing calculator. That's fine. There is this thing on the World Wide Web called Desmos. I encourage you to use it. If you're ever curious about a graph, you want to understand graphing better, I strongly encourage everybody to use Desmos. Desmos is awesome. It is a beautiful free graphing calculator. And the window is pretty much square. So if I graph this function that we started with, this -x, was it -x minus 2, I believe? Okay, and then I graph my second one that I think it's going to be x. I can look at those and I can look to see, do those look to be perpendicular? It looks like it to me. Looks like it to me. Any questions, comments, concerns, short debates about number 9? Do you have to have a plus or minus after the g? No, as long as you had g of x equals x, that's fine. If you had like plus 11, I wouldn't even be mad at you. Yep, g of x equals x plus or minus anything. You don't need to have the plus or minus anything. Good question. Cool. All right. Well, I guess we're trucking right along. Number 10, I think, is on the next page. There it is. Number 10 asks the question, how is this related to the parent function? And then they want us to graph it by translating the parent function. So I guess I'll put that on a new page. We'll lock that down. I'll go ahead and start by graphing the parent function. So when I graph the parent function, we know it looks like that, more or less. And it'd be really nice if you had digital notebooks like this, wouldn't it? Where you could drag things around like that. Wouldn't that be cool? So let's see, we have y equals x take away 3. Anybody have any idea what kind of translation that's going to be? What language we use? We don't want to use the move word. What are we thinking? We know where it goes. If it doesn't go down 3, which way does it go? Down 3 or right 3, right? Parentheses like that means right 3. Parentheses like that means down 3. But what do we say? We just can't say that. There's language we got to use. When it goes down 3, we call that a what? When it goes down, it's actually a vertical translation. So we say it's a vertical translation down 3. And or a horizontal translation right 3. Okay? And again, on these, I'm more concerned that you can describe this than graph it. I won't say I couldn't care less that you could graph it, but I'm more concerned that you can describe it than graph it. So I'm going to drag it down. If I drag it right, it ends up in the same spot, down 3 or right 3. Down 3 or right 3. There's number 10. Anybody have number 10 right? What I want you to think about, too, especially as we get ready for Friday with the quiz, I really want you to try to use that language, the vertical translation down 3. Horizontal translation right 3. Okay. Any questions before we look at 13? All right, 13 wants us to make a table of values, and they're telling us that this thing is translated 3 units up. So what I want you to think about is that 3 units up means the y values all will be plus 3. All the y values are going to be 3 plus 3 bigger than they were to start with. Now, if we look at that table, it's pretty clear the left column is our x values, right? What's the right column represent? It doesn't say it, but what's the right column represent? Somebody said it. The y values. If you recall yesterday in the notes when I was introducing the parent functions, I said the parent functions are y equals f of x, which equals x. Remember when I said that? Like that's a parent linear function. This statement right here, it's a real subtle thing, but it is a thing. So what the deal is this column represents all the y values. F of x and y mean the same thing. So then when we have this thing 3 units up, it's going to be f of x plus 3 like that. And all of our y values are going to be 3 more than they were before. So the one that corresponds with the 3, of course, is going to be 3 plus 3, which is 6. And then the one that corresponds with 1 is going to be 4. And then the next one, negative 2 plus 3 would be 1. And negative 1 plus 3 would be 2. Okay. How'd we do with number 13? Does that make sense? Okay. Cool. Cool. Today's one of those gloomy days, isn't it? Raining outside. Everybody just wants to go back, crawl under the covers, sleep a couple more hours, eat a couple Oreo cookies, and drink some milk. And yes, I did say milk because that's the way you say it. Milk. All right, number 17. They want you to write an equation for this vertical translation. They want you to write an equation for this vertical translation, y equals f of x. So we're going to write f of x, and they want it 4 units up. So we're going to have to put the number 4 in there somewhere. Maybe we multiply by 4, maybe we divide by 4, maybe we subtract 4, maybe we add 4. Maybe we add 4 in the parentheses, maybe we add 4 at the end. Anybody know where we add the 4? Or multiply by 4? Or where we put the 4? At the end? So is it going to be plus 4 or minus 4? Plus 4, like that. Good. Plus 4, like that. There it is. Nice. Good. What do we think of 17? Would it be wrong if you put y equals x plus 4? That's a good question. See, in this problem, they're telling us that our function is found by taking the y values which are equal to f of x. So they're not clearly defining any function. So f of x is vague in this case, or it's ambiguous. What I mean by that is we don't know exactly what f of x is. So the question was, what if I had x plus 4? Well, if you did that, then you're saying that the original function was y equals f of x, which equals x, the parent linear function, and they didn't necessarily tell us that. So when they're saying this f of x, they're just saying we don't know what the function is, but it is some function. Okay, good question, really good question. Yeah, so that's why we have to leave it as f of x, because we don't know what it is. This reminds me of when I was in calculus. Did I ever tell you about what happened to me when I was in calculus? So Calc 1 did really good, got an A in it. Calc 2, the professor spent the first 6 weeks of class catching everybody else up from Calc 1, because half the people in my Calc 2 class didn't learn Calc 1. The final exam made up 70% of our grade, and the notation on it was totally different than anything I had seen. It was written by a different professor altogether. It was a department final. I had no idea what I was doing. I got a D on it, got a C in Calc 2. Almost lost my scholarship. So if you are ever not sure about the way we're writing things or the language that we're using, please ask questions. Please ask questions. It's real important that you get the language, that you get the notation. All right. So number 19 is the next one. We're getting there. We're almost done with this. 19's next. So for each function, they want us to identify the translation of the parent function and then graph it. So they want us to identify the translation and then graph it. And if I'm being honest with you, the graphs, they don't have to be anything spectacular. We know the parent function x squared kind of looks like this. Looks like that. So what kind of translation's going on here? It's moving it, so it's a translation of some sort. Translation, a vertical or horizontal translation? Horizontal translation, so it's a horizontal translation. And you might think that it's 4 units one way, but it's actually counterintuitive. This is 4 units to which way? 4 units to the right. Nice. 4 units to the right. So when you graph this, really all you got to do is just kind of do something like this. That's good enough. That's all we want. Just something like that. That's good. Doesn't have to be anything super duper uber spectacular. At least not yet. Who had that one? Anybody? Awesome. Good. Any questions about 19, about why it's translated to the right and not to the left? About why it's the opposite of what you'd expect it to be? Huh? It's not the exponent, no. Because when we have an absolute value function, it does the same thing. Let's look at an absolute value function. Where's all my stuff here? There it is. Okay. Get that out the way. So if I have an absolute value of x, looks like that, right? And if I have an absolute value of x minus 4, it also is 4 units to the right. So it's not the exponent that does it. So my question is, why is that thing going the opposite way? It's like an inequality, kind of. So it has something to do with an inequality? No, but you're kind of onto something with thinking about the inequality thing. So my question is, why is x minus k a translation right and not left? That's what my question is. Why is x minus k, or f of x minus k, I should say. Why is f of x minus k, why is f of x, oh dang it, I wrote it wrong. Why is f of x minus k a translation to the right and not the left? What it has to do with, regardless of the type of function it is, whether it's a parabola, whether it's a v, regardless of the type of function it is, it has to do with the vertex. It has to do with that high point or low point. So let's just look at one of these absolute value ones for a minute. Okay. Let's just assume that the lowest point on the graph is the x-axis. Lowest point's the x-axis. Suppose we had something like y equals x minus 4, just like that, in absolute value. Our y value that represents the lowest point on the graph is what? What number represents the lowest y value on the graph? Anybody? What number could I replace y with if I'm trying to find the lowest point on the graph? Not 1. It's all the way down here on the x-axis. 0. Okay. So what I've got then is this equation that says, okay, 0 equals x minus 4. So I want to know what x value. I want to know what x value corresponds to that y value. So I'd have to solve this equation. And when I solve this equation, I'm going to have to add 4 to both sides. Do you see how that number has to go to the other side of the equation when you do that? That's why it's the opposite of what you think. I don't know if that made sense or not, but that's why. All right, where did we leave off? 22b? 22b. 22b, they want us to graph this if we have f of x plus 3. So f of x plus 3 is going to be a translation which way? Translation which way? To the left 3. So that's a horizontal translation to the left 3. So this point here is going to be over 1, 2, 3. It's going to be over here. This point here is going to be 3 to the left. 1, 2, 3. This point up here is going to be 3 to the left. 1, 2, 3. And this point down here is going to be 3 to the left. 1, 2, 3. So the shape's going to be the same shape. Barrel, barrel, barrel. That's what you should have had. I saw a couple people when I looked at their paper, they had that thing up 3. It's actually 3 units to the left. That's 22b. Question. So why didn't I move it to the right? So in yesterday's notes, what we talked about was with these horizontal translations, a horizontal translation is when we have f of x plus k like this into parentheses. So if we had y equals x minus 5 squared, or y equals the square root of x plus 8, or y equals the absolute value of x plus 2, all of those are going to be horizontal translations. Why? Because we're adding or subtracting stuff inside the parentheses. And what we said yesterday is that these are counterintuitive. Now that's a fancy way to say, we said they're counterintuitive. That's a fancy way of saying it's the opposite. It's the opposite of what you'd think. It's the opposite of what you'd think. You'd think minus 5 means to the left 5. But this minus 5 means right 5. You'd think that plus 8 means right 8. But it's the opposite of what you think. So it's left 8. So with that horizontal translation, it's always going to be the opposite of what logic would tell you. Good question. Good question. It's going to be one of those things that's going to come up again in chapter 4. It's going to come up again in chapter 5. It's going to come up again in chapter 6. It's going to come up again in chapter 8. Any other questions before we look at 26? Okay, 26 must have been on that last page here. 26 wants us to write an equation for a vertical stretch by a factor of 4. So when we stretch something, we're no longer adding. What are we doing when we stretch something? We have to have skills in multiplying. Y equals 4 times x is what you should have had there. Y equals 4 times x. Anybody have that on 26? Y equals 4? Okay. It's got to be 4x. Because they're telling us we're transforming this function. This function is defined by x here, so we got to take that x and quadruple it. So y equals 4x is what we're looking for there. Okay. Moving right along then, 32. 32, they want the transformations that went on here. This is a tough one. This is kind of tricky to figure out. I will give you a hint. There's three things that happen in this one. Three things. It is a vertical stretch by a factor of something. It is a reflection about some axis. And it is some kind of translation, 4 units some way. See if we can figure this out. Vertical stretch by a factor of how much? Not 2. We had x over 2. This is kind of tricky, and they like to sneak this in on you. What's x's coefficient there? What's x's coefficient there? X's coefficient's not 1. X's coefficient there is this number that's sitting right out front. Well, I guess this 2's part of it. But what's in the numerator up there next to x? Isn't there really a 1 up here? So x's coefficient here is 1/2. And x's coefficient over here is 2. It's actually negative, but what do you multiply a half by to get 2? Somebody said it. What do you have to multiply a half by to get 2? 4. So this is a vertical stretch by a factor of 4. It's a vertical stretch by a factor of 4. What axis does this thing get reflected about? They put the negative sign in front of the whole function. So it's a reflection about the x-axis. And which way does this thing get translated 4 units? 4 units to the right, to the left, to the up, or to the down. You might think 4 units to the left, but that's not in parentheses. If it were in parentheses, it'd be 4 units to the left. But it's not in parentheses. The parentheses are kind of here. 4 units up. So it's going to be 4 units up. So that's going to make it a vertical translation. Okay. On Friday's quiz, there's going to be a question just like this. Describe the transformations from this to this. Okay. Got 2 more. 40 and 51. Number 40. So they want us to talk about how the domains and ranges change if we have a vertical translation. If we have a vertical translation, the domain stays the same. Stays the same. If we have a vertical translation, that's going to translate the thing up. The domain's going to stay the same. The range increases or decreases. The range changes, I should say. The range changes. The range changes. If we have a reflection across the x-axis, that's going to change both the domain and the range. That's going to change the domain and the range. Well, is it? No, it's not going to change the domain and the range. Oh, shoot. So they're saying if we take this thing and we flip that over, does the domain change or does the range change? Actually, neither changes. Wow, I'm glad I looked at that. No change. If we have a vertical stretch, we're going to make this thing higher. We're going to make this thing higher. Does that change the domain? Doesn't change the domain. So the domain stays the same. The range changes. The range Increase as if it's a stretch. The range would increase. In a horizontal translation, if I translate this thing, if I take that thing and move it somewhere, horizontally though. If I move it horizontally, so just this way, that's going to change the domain. That's going to change the domain. The domain changes. The domain changes. Range stays the same. That's a tough question. That's a higher level thinking question. Part B, do you think these effects hold true for all functions? I guess it depends on the function, and we'll talk more about that later this year. That's going to depend on the function. Number 40 is a really tricky one. If that one just went over your head, don't worry about it. That's no joke. Last one, 51's a multiple choice. Standard test prep question. They're saying we're going to take this thing and move it down or translate it down 3 units. Anybody think they got number 51 figured out? Mr. Massey always says go with C. Mr. Minnick always says go with B. The Fonzarelli, Henry Winkler always used to say A, but none of them are right. What's the right answer here? D as in dog. It's been real. It's been fun. I'd like to give a shout out to the future Mr. Minnick. He's probably in the back grading papers. Or maybe he's taking a nap because it's a gloomy day. Or maybe he's dreaming up another cheesy joke. Regardless, have a great day. See you next time. Good.